Welcome to Context Window, your weekly look at the bleeding edge of AI coding tools. Let's see what's new.
A single press of the Tab key. That's all it takes, according to new research, to give a sophisticated attacker root access to a developer's machine.
And not just any developer, but one using some of the most popular AI coding assistants on the market today. It's a vulnerability that weaponizes trust in a way that's profoundly unsettling.
Unsettling is an understatement. Before diving into the details of this TrustFall vulnerability, what's been happening in the world of AI coding tools this past week?
Kicking things off, OpenAI's Codex API recently saw an update, with reports indicating a significant expansion of its context window for enterprise-tier users.
Larger context windows typically mean more robust and relevant code suggestions, but there's a question about the cost implications for businesses, particularly as they scale. Is the enhanced quality truly justifying the increased token usage?
Precisely. Meanwhile, Anthropic's Claude 3.5 Sonnet continues to impress in coding benchmarks, especially in complex reasoning tasks. The push seems to be towards solidifying its position in enterprise development environments.
That's a clear strategic move, aiming for the high-value corporate contracts where code quality and robust API performance are paramount. It suggests a focus on reliability over bleeding-edge, unproven features.
Over at Google, Gemini 1.5 Pro has deepened its integration with VS Code, focusing heavily on multimodal understanding of entire code bases. This means it's not just looking at snippets, but trying to grasp project-level context from documentation and related files.
That's an interesting direction, moving beyond simple code completion to something more akin to a code-based assistant. The real test will be how well it manages to synthesize disparate information without hallucinating or introducing subtle bugs.
GitHub Copilot, on its part, quietly rolled out an explain code feature, allowing developers to query its suggestions. However, some users are reporting a subtle but noticeable shift in the overall quality and relevance of its core code suggestions, sparking debate on forums.
So, a new feature, but potentially at the expense of its core strength? That could be a difficult trade-off for developers who rely on Copilot for raw code generation speed. It raises questions about model tuning and resource allocation.
Cursor, a tool built specifically around AI-first development workflows, announced enhanced project-level context indexing. They're aiming for even more relevant and tailored suggestions across very large multi-file repositories.
That's a direct response to the challenge of managing complexity in enterprise-scale projects, which is where many of these AI coding tools struggle. The better the context, the less generic the output.
Finally, a new player, Windsurf AI, has surfaced touting what they call self-correcting code generation capabilities. It's still in private beta, but the buzz suggests they're aiming to address the issue of iterative refinement directly within the AI model itself.
Self-correcting is a bold claim for an AI code generator. It will be fascinating to see if they can deliver on that promise, especially given the current challenges with reliability and error propagation in AI-generated code.
The idea that a single keystroke can grant root access is alarming. Can you break down how this exploit actually functions? What happens when a developer presses Tab on a malicious suggestion?
The simplicity is precisely what makes it so dangerous. Researchers demonstrated how AI coding assistants like GitHub Copilot, Cursor, Codium, and Code Whisperer could be coerced into providing malicious code suggestions. The crucial step is the developer accepting that suggestion, often with a simple Tab key press. This action then executes a payload embedded within the suggested code. The suggestion might look like a harmless utility function or a common dependency installation, but it contains a hidden command. So the AI isn't inventing the malicious code out of thin air. It's pulling it from somewhere. Where does the venom come from before it even reaches the AI model?
Exactly. This is a supply chain attack at its core, a sophisticated form of what's known as supply chain poisoning. Attackers inject malicious code into seemingly innocuous open-source packages. They might contribute to popular repositories, create subtly compromised versions of widely used libraries, or even exploit vulnerabilities in existing projects to insert their code. These poisoned packages then become part of the vast data set that these AI coding tools draw from when making suggestions. It's like a library where a few books have hidden, dangerous passages, and the AI, in its effort to be helpful, inadvertently recommends one.
Many of these AI tools boast about sandboxing or security checks. Why aren't those catching this? Why isn't the AI smart enough to flag something obviously malicious before it's presented to the developer?
The key here is the human in the loop. The AI tools do have safeguards. They might warn about executing unknown scripts, or they might try to sandbox generated code within the IDE environment. However, the TrustFall attack bypasses this because the developer explicitly accepts the suggestion. The system interprets that tab keypress as an intentional act, a direct command from the user to insert and then execute the code. This moves the responsibility from the AI's internal automated checks directly to the developer's judgment and trust. It's not a flaw in the AI's ability to detect malice as much as it is a flaw in the interaction model that grants user intent and overriding authority.
So it's exploiting the trust developers place in these tools. Developers have been conditioned to trust these tools to make their lives easier, to autocomplete, to suggest efficient code. Is it a cognitive bias at play here? A kind of automation complacency?
Absolutely. Developers often operate under significant time pressure to deliver features and fix bugs. There's an inherent trust in tools that promise to accelerate workflow and reduce boilerplate. When an AI offers a suggestion, especially one that looks plausible and fits the current context, there's a strong tendency to accept it without rigorous manual review. This is particularly true for common boilerplate, utility functions, or dependency installations, which are often perceived as low risk. It's an instance of automation bias applied directly to code, where the perceived efficiency of the tool overrides critical manual inspection. The developers are quite literally falling for a trust fall because their tools have fostered an environment of implicit trust.
This moves beyond just an individual developer's machine, doesn't it? If a single developer's machine is compromised with root access, what's the ripple effect for their organization, for the broader software supply chain?
The implications are significant and systemic. Root access on a developer's machine often means unfettered access to internal networks, sensitive source code repositories, API keys, credentials, and intellectual property. This is a direct vector for a supply chain attack against an entire organization, similar to what we've seen with other high-profile software supply chain compromises, but with a novel AI-assisted twist. One compromised developer can become the entry point for a much larger breach, potentially leading to data exfiltration, system sabotage, or the injection of further malicious code into critical software products that then get shipped to customers.
This sounds like a really hard problem to solve. It's not just a patch for a specific bug or an update to an AI model. What are the researchers suggesting, and what's the broader path forward to mitigate this kind of vulnerability?
The researchers emphasize that there's no simple software patch to address this. The vulnerability lies in the fundamental interaction model itself, an AI tool suggesting code from an inherently untrusted public source and a developer blindly accepting it. Proposed solutions include drastically improved UI/UX design within these AI coding tools, specifically to differentiate trusted versus untrusted code more clearly. For instance, suggestions derived from verified internal repositories might appear differently than those pulled from arbitrary public code. They also suggest more robust static analysis of suggested code before it's even presented or accepted, going beyond mere syntax checks to deeper security analysis.
So, a more proactive security posture within the tools themselves, rather than relying solely on the developer's vigilance.
Exactly. And beyond that, there's a call for a complete rethinking of how AI tools integrate with public code repositories, perhaps involving a form of provenance tracking or reputation scoring for code sources. But ultimately, it requires a significant shift in developer mindset and security practices. Developers need to approach all AI-generated code with a healthy dose of skepticism, understanding that even the most advanced AI can inadvertently become an accomplice in a sophisticated attack.
So, to summarize the key insights from this research, first, the TrustFall vulnerability weaponizes the inherent trust developers place in AI coding assistants, turning a productivity feature into a security liability.
Second, it's a novel form of supply chain attack, leveraging poisoned open-source packages to inject malicious code into developer workflows. This isn't about AI generating bad code, but about it retrieving compromised code.
Third, existing AI security features are largely bypassed because the developer explicitly accepts the malicious suggestion. It's a human-in-the-loop problem where user intent overrides automated safeguards.
Fourth, the risk extends far beyond individual machines, posing a significant threat to organizational security and the integrity of broader software supply chains. One compromised developer can initiate a cascading breach.
And finally, there's no quick fix. Addressing TrustFall demands a fundamental reevaluation of AI developer interaction design, a significant upgrade in tool-based security analysis, and a heightened, sustained sense of vigilance from developers themselves.
For listeners, what does this ultimately mean for the future of AI-assisted development? Where do we go from here, balancing utility and risk?
The question becomes, how do we balance the undeniable productivity gains of these tools with the critical, non-negotiable need for security? Can we rebuild that trust through better design and transparency without sacrificing the vigilance that this research so clearly demands?
That's all for this episode of Context Window. Join us next time for more on the AI tools shaping how we build software. If you're building with AI, subscribe. We cover what matters.
Ship smarter, not harder.